We tend to view the laboratory as a place of absolute order. It's a sterile environment where variables are controlled, reactions are predictable, and the messiness of life is kept firmly behind glass. Then there's the theater of William Shakespeare. Here we find the exact opposite: characters acting on impulse, lovers defying logic, and kings making disastrous choices fueled by paranoia. It looks like pure chaos. But if we look at these plays as a collection of data points, we find that the dramatic structures Shakespeare built often mirror the very systems we use to describe the physical world. To see how, we can analyze his work across 3 different scales of magnitude. We'll start at the microscopic level of atomic bonds between individuals, move to the biology of social groups, and finally examine the macro-level mathematics of falling empires. Human emotion is not random noise. It is a structured system, functioning with a logic that bridges the gap between the stage and the lab. At the micro level, A Midsummer Night's Dream presents a romantic dispute that functions remarkably like a study in chemical affinities. Hermia and Lysander have aligned their orbitals to form a stable covalent bond. They share electrons. When Hermia's father attempts to force an ionic bond with an outsider, Demetrius, the existing molecule resists, repelling the incompatible element to maintain its structural integrity. We see similar mechanical limits in Othello, though here the variables describe a catastrophic phase transition. If we track Othello's mental state, we see his trust decaying exponentially under the force applied by Iago. As trust approaches zero, the rising energy of his jealousy crosses a critical threshold. At this point, the system undergoes a state change, making the shift to murderous rage irreversible. At the microscopic level, human bonds and emotional fractures follow the same predictable patterns as physical attraction and energy thresholds. When we zoom out to small social groups, the rules shift from physics to evolutionary biology. In Love's Labour's Lost, a group of scholars swears a rigid vow to avoid romance and isolate for study, but the vow disintegrates almost immediately. This collapse reflects a biological drive. In nature, isolated, rigid systems struggle to survive. Adaptation and exchanging information are required to sustain the group. Microbiologist Carl Woese identified how early life used gene transfer to build complexity. When the scholars break their vow to interact with visiting researchers, they are following that same evolutionary protocol, trading information to build a stronger, more complex network. We see this again in Much Ado About Nothing, where group biases act like gravitational lensing. The characters' preconceived beliefs warp the incoming data, distorting their ability to see the objective truth. Social groups are complex adaptive systems. To persist, nature requires them to bend, interact, and continuously reorganize themselves to survive the changing environment. Finally, we reach the macro scale, the survival or collapse of an entire state. For this, we can look at the statistical game theory embedded in Macbeth. This matrix maps Macbeth's decision. The prophecy updates probabilities, making act his optimal path. To maintain control, Macbeth adopts a grim trigger strategy. His central node radiates coercion, punishing Thanes. As safety vanishes, nodes link up, making a coordinated rebellion the only rational move. Macbeth relies on a flawed risk calculation, the prophecy that no man born of woman can harm him. Macduff, born via cesarean, exploits that loophole to collapse the regime. At this scale, illegitimate authority and coercion inevitably trigger a systemic collapse, following the cold logic of a statistical model. From the atomic bonds of young lovers to the political matrices of falling kings, the patterns remain consistent. We often separate the sciences and the humanities, but they are frequently describing the same phenomena. Equations can capture the movement of emotion, and drama rests on a foundation of structural logic. Trust decays, groups adapt, and regimes overreach. When we track these movements, the line between a biological drive and a dramatic arc starts to disappear. Shakespeare didn't need calculus or game theory to understand the forces governing the human heart. To see how these universal systems function, sometimes you just need to read a play.